Hey guys, today we are going to present our laboratory project about the LED flasher system using PIC microcontroller. And this, my name is Ho Jason, which my metric number is 2240184.
My name is Muhammad Fidos Gamaruzi and my metric ID is 224186. My name is Damia Marisa and number metric is 220157.
Okay, in our project, today I'm going to introduce about our introduction, safety, design, challenges, and final result in our report. Lastly, we will make some conclusion about our project. In this laboratory experiment, we are learn to how to use the microcontroller-based system development and also converting the circuit design in some apps, while also stimulation the circuit design by using the multisim and multiboard. And then we are trying to learn the hardware implementation, including the PCB board fabrication using the multiboard. In this laboratory experiment, we learn some theory and also the practice in embedded system and electronic hardware design. In this laboratory experiment, we have to make sure ourselves in safety, which we always have to wear the complete personal protective equipment like this. And also, generally, we know that we cannot bring the foods and drinks because we have to avoid the contaminated and also accidental ingestion. Secondly, we must always wear the chemical resistant gloves to protect our hands, and also before we doing in chemical safety, we always have to wear the chemical resistant gloves to protect our hands, and also before mix any chemical substance such as etching or cleaning, we have to handle the chemical things in a well ventilated area to avoid the harmful vapors. And thirdly, in any electrical soldering safety, we have to make sure to always power off and also unplug the circuit before working, and also wear the gloves that is heat resistant while doing the soldering process. Make sure we have to use the film extractor such as this one in soldering process so that to avoid the inhaling harmful fumes. However, before the soldering part, we have to do the drilling for the PCB board. In this PCB board, we have to secure the PCB board with clamps to prevent slips and contact. But before that, we must always wear the safety goggles to protect our eyes. Or from that, what if we happen some accident? Of course, we have to contact what if we really happen the accident in laboratory happen accidents? We must ask for help and quickly get treatment with lab assistant.
Okay, here's come to my part, which is PCB design and planning. We use modern tools, and then the design and planning are divided into three parts, which is A, B, C. Okay, we go to the next slide. Yeah, the modern tools we use is multisim. National Instrument offer a multisim, a window-based tool for analog and digital board level. Engineers can create model and simulate circuit interactively. So we use multisim for our project. Next slide. Yeah, this is the step-by-step on how to produce a PCB board. Okay, we start from create circuit on multisim, simulation, test on breadboard, design circuit on multiboard, print on copper board, etching, continuity test, drill holes, and then the last part, which is soldering component. Okay, the next slide. So yeah, this is our schematic diagram of a main circuit. This is given by the lab sheet, so we just copied it. Okay, next slide. Okay, so come to the part where Jason. Yeah, I will explain the step later, but first we test on the breadboard first.
In this breadboard testing, we know that there is a LDR, which is the light detector sensor, is making the third LED. Okay, in this first, the third LED is according to the LDR sensor, which is a light dependent sensor. When it is in light region, it will be off, and while in the dark region, it will be light up. And the first switch is controlling the first LED. When it is on, the LED will be off. And of course, when it is off, the switch is off and the LED will on. However, at the second switch, it will light out when will light out the second switch, which is this one, when it is on.
Oh yeah, so this is a design on a multiboard. This is designed by Jason and Firdaus. It's quite complicated, but it's basic. Next. Okay, so there's a component named PIC. So the component need to be programmed, has its own package. So this is the coding. Okay, next. Okay, this is the PCB making process that I will explain. Next. So the first design on multiboard, and then we print it on the paper, and then we print it back on this machine, compression machine. Yeah, compression machine to copy the paper into the copper board, and then it is hot, and then we cool it down into the cold water. Okay, and then next slide. And then after we cool it down, we put the board into the chemical substance. This is what we call the etching process. Okay, what is etching? It's a process that use chemical or other means to cut or erode a design into a material. Okay, and then after we etching, we dry it, and then we do a continuity test. It's performed to verify the presence of a complete and unbroken electrical path with inner circuit. So we need to check if there is electricity going on every circuit. And then after we do continuity test, come to the part where we drill a holes to insert the component. So we use 0.4 millimeter and hole, and then we use 1.0 mm for the drilling. And then after we drill all the holes, come to the last part, which is soldering. And then soldering is used to join the metal part using a lower melting point filler metal. That metal will melt, and then the component and the circuit will join. Next. So after soldering, and then we got our final, which is we put the battery on, and then we test, and then it is working well. Done.
Alright, for the final result, for the PCB and measurements, we using multimeter to check the value of voltage that go through the LED. And when that we got this value, we got 0 until 5 based on the according conditions. And we can see that when we change the switch, we got different result. We can see that LED does not light up, and we got LED light up. And also we have the LDR that determine the surrounding condition. And when the condition is light, the LED will not turn on. And if the condition surrounding is dark, and then the LED will turn on. Okay, here is the result of the measurement on PCB. Okay, we're using the oscilloscope to measure the frequency of the LED. By setting the frequency to 5 Hz, we got different value. And this percentage indicate the brightness of the LED. We can see that when condition number 1, when switch 1 is off and switch 2 is off, we got 40%. Switch 1, condition 2, switch 1 on, switch 2 off, we got 20%. And the condition is switch 1 off, switch 2 on, we got 80%, the highest or the brightest LED bright. And the final condition is both switch is on, and we got only 60%. And the condition LED, we can see on off this value indicate that the blinking of the LED, the frequency of the blinking of LED. And here the estimation cost according to our mini project. The conclusion, the laboratory project successfully demonstrate the practical application of PIC using microcontroller system to control LEDs based on input such as switches and LDR. And after that, we also understand of digital logic interfacing the hardware software integration. And finally, we can say that we gain from this laboratory experiment, we gain practical experience like in circuit simulation, physical like etchings and drillings and soldering that will help our features during the works. Right.
We can apply it for ourselves. Like we're creating for our FYP project, which is more complex, and this one is like a basic one. So when we apply on our FYP, and then we go to our job, our scope, and then we use this electronic.
That's all.
Okay,